Morning Science 20s. Our lesson today is going to be telling the difference between an electrolyte and a non-electrolyte and trying to figure out when is something going to be an electrolyte or when it's not going to be an electrolyte. So let's get started. Well, if we take a look at this, the simplest definition of an electrolyte is a compound that produces ions. Remember, an ion is something that is charged. So when I drop a compound, a solid, a crystal, whatever it is, into water and it dissolves, does ions get produced? If they do, that is going to be an electrolyte. So I want us to think, is an ionic compound going to be an electrolyte or is a molecular compound going to be an electrolyte? And that's what I would like us to think about today. So if I take a look at some of the properties of molecular compounds again, molecular compounds are composed of two nonmetals or more, of course. So something like sugar would have three. Molecular compounds share electrons, right? This is where we put them together and the valence levels are sharing to get to that full bus. And secondly, molecular compounds do not conduct electricity. The reason they don't conduct electricity is molecular compounds do not break into ions. They stay together as molecules. So if I'm thinking about this, I would say that a molecular compound would be a non-electrolyte. Now, let's think about ionic compounds then. An ionic compound is made up of a metal and a nonmetal, or as I like to say, a cation and an anion. Well, those are ions. They're positively charged. Remember, a cation is positively charged and anion is negatively charged. So there's ions present. We're going to transfer, one's going to lose, one's going to gain electrons. And because these charges are in the solution, it will for sure conduct electricity. Therefore, ionic compounds are going to be classified as electrolytes because they have charges, they have ions. So we're going to clear this slide for us. Let's move on to the next slide. So I want to take this exact same example again. This time for molecular, let's look at something like sucrose. Here is sucrose over here. And I'm going to get my pen going. Sucrose is C12H22O11. Now, if I take a scoop of sugar and I drop it into water, it doesn't break down into ions. Yes, when I drop it into water and I stir it, it's going to disappear. But notice C12H22O11 sucrose still, once I dissolve it, becomes C12H22O11 sucrose. The only thing that changes is it goes from solid to aqueous, meaning it dissolves in the water solution. It does not break up into charged particles. Therefore, if I test this with a conductivity tester, this is not going to conduct. This is not an electrolyte. That is very different than if I take table salt, NaCl, and I drop it into water. And again, I take a scoopful, I stir it. It's going to break down into sodium ion and chloride ion. It's going to break into ions. And notice the water is going to peel off a sodium. And because it's positively charged, in the last video we saw, hey, water surrounds it with its negative oxygen side. When it's negatively charged chlorine, water surrounds it with its positive hydrogen side. And because of these ions, we know for a fact that salt or ionic compounds are electrolytes. This is also true for acids and bases. They're also electrolytes. And so let's take a reason of why I can say that with such certainty. So if I take a look here, acids by definition are ideally a specific type of ionic compound where the cation, the positively charged ion, is always hydrogen. So when HCl, the most famous acid, dissociates or breaks into its ions, we are left with hydrogen ion and chloride ion. Well, all acids have hydrogen ion, and since all acids break into ions, we know for a fact acids are electrolytes. So true is that for bases. However, bases are a specific type of ionic compound where the anion, the negatively charged ion, is always hydroxide ion, which means when sodium hydroxide dissociates, it's going to break into sodium ions, got a charge, and hydroxide ion has a charge. All bases will have hydroxide ion. Since there's an ion, we know we're going to say acids and bases also are electrolytes. So here's what I would like us to try. I would like us as a group to try naming these 6 as ionic or molecular and figuring out, are they electrolytes or non-electrolytes? I'm going to do the first six for you, and then I'm going to flip a page. There's going to be 6 more, and I'm going to have you pause the video and try those. I want to remind us before we start that ionic compounds always contain a metal. That's how we tell them apart between ionic and molecular. If there's a metal, it's an ionic compound. So NaCl. There, sodium is a metal when I put my finger on it. Therefore, this is going to be ionic. Since it's ionic, we know it is an electrolyte. Spelt it wrong. Number 2, C6H12O6, non-metal, non-metal, non-metal. 2 or more non-metals. That is going to be molecular. This is going to be a non-electrolyte. KBr, put my finger on it. Potassium is a metal, therefore it's ionic. This is going to be an electrolyte. AgNO3. Ag, silver, is a metal, therefore it's ionic. This is also, why do I keep spelling it wrong? Going to be an electrolyte. And last but not least, P4O10. Phosphorus is a nonmetal, oxygen's a nonmetal. This is going to be molecular. Therefore, this is a non-electrolyte. So let's clear this, get rid of my spelling mistakes, because that's pretty bad over and over again. And what I would like you to do is pause the video right now, copy this into your notes, and I would like you to try these 6 for yourself. Then when you're done, unpause the video to check out my answers. Pause now, please. Okay, so I'm going to do these. AlCl3, this time we're adding in an extra, ionic molecular acids bases. So we have a metal Al, so we're going to say this is ionic. Ionic is, of course, an electrolyte. H2SO4, again, H starts with H and then SO4. So my cation is hydrogen. This actually is sulfuric acid. So since this starts with a hydrogen ion, we're going to call this an acid. Acids are also electrolytes. C12H2211, non-metal, non-metal, non-metal. This is actually our example of sucrose. So this is molecular. This would be a non-electrolyte. C2H2, non-metal, non-metal. This is also molecular. This would be, again, non-electrolyte. CaOH, so starts with a metal, but it also ends with hydroxide. So this is a special type of ionic. This is a base. So it is also an electrolyte. And last but not least, Na, this is my metal. So sodium sulfate, this would be ionic. This is also an electrolyte. I hope you're able to use what we've learned today to go forward in our understanding, but also to figure out some stuff for the lab you're about to do.